Hello, I thought I'd try and do what's called a walking talking mock. I'm going to show you this exam question. It's at the end of a foundation P2 AQA paper, so it would be at the beginning of a higher paper. So we're just going to work through this and I'm going to show you how to answer it and key things that I'm doing in order to make this make sense. So it says the diagram shows a circuit used to investigate the resistance of a material. So here's the material. They're investigating the resistance of it. The diagram is incomplete. The ammeter and voltmeter are missing. Draw the symbols for the ammeter and the voltmeter on the diagram in the correct places. 2 marks. This is one of these questions that people quite often miss out because there aren't any lines here to write the answer in. What you need to be doing is looking for where it says here 2 marks. Look here, we've got 1 mark. So look, 2 marks here for drawing the ammeter and the voltmeter. Now, because we're measuring the resistance of that material, what we need to do is make sure that we draw the voltmeter over the material. Remember, voltmeters are always in parallel. The way to remember that is whatever is the material you're talking about. Look, a V you can draw over it, okay? So we draw it like this. There's the voltmeter over it. The ammeter has to go in series. So there's the ammeter in series, there's the voltmeter in parallel, and they're in the correct places. So then it says, how can the current through the material be changed? Well, hopefully you've noticed here we've got 4 cells giving a total potential difference of 6 volts. How can the current be changed? Well, here's the last thing to notice. We have a variable resistor here. Remember that arrow across the variable resistor is like a dial. You can turn it, it's like a dimmer switch. So how can the current through the material be changed? Alter the variable resistor. Okay, 1 mark, so we just need something simple for that. So the material that we're talking about, called conducting putty, is rolled into cylinders of different lengths, but with equal thicknesses. So they're giving us some information there. They've changed the length, but they've kept the thickness equal. So graph 1 shows how the resistance changes with length. Here's the resistance increasing. Here's the length increasing. And we can see a positive correlation. So the question says, why has the data been shown as a line graph rather than a bar chart? So why have we got a line graph here, a scatter graph with a line of best fit? Well, hopefully you know that this is what we use for continuous data, where it can be any numbers, yeah? If this were to be a categoric data, we would have to have a bar chart. So our answer here is continuous data is shown as a line graph. Or we could write, because the data is continuous. Then it says, the current through a 30 centimetre length of conducting putty was 0.15 amps. Use graph 1 to find the resistance. So it's telling you, use the graph. This isn't a calculation. It's giving you information. It says use the graph. So use the graph to find the resistance of a 30 centimetre length of conducting putty. And here we've got to write the resistance in. So 30 centimetres. Let's go back to our graph. So 30 centimetres. So here's our 30 centimetres. And you can see I can't read that off. I need to continue the line. Now, ideally, I need a ruler for this. I know sometimes you forget rulers, but you might have a pencil. So we can just continue it with something straight, like the edge of a pencil. So here we go, 30. Let's read that off. It's around about 36. So 36 ohms. I'm about reading that off. Okay, now the next question is asking you to do a calculation. In the new scheme that you guys are all following now, these equations are all on the equation sheet separate. You have to go and look them up. This is an old question, so it's from the old scheme, so they've got the equation there. It's still pretty easy to find the equations, but I'll cover that another time. So it says, use your answer to BI. Now that's here. Okay, so that answer. Use your answer and the equation in the box to calculate the potential difference across a 30 centimetre length of conducting putty. So we're calculating the potential difference, and that is the current times the resistance. Well, it's saying use your answer. So we've got the resistance, right? So we know it's 36 because we did it. Now, where is the current? Because it's not in this question, is it? It's just asked you about the 30 centimetre length. Well, this is where you remember, you know these annoying numbers here? They all mean it's part of the same question. All of this is the same question. Look, it's question 6. So this is all part of the same question. So here, current, we just need to look backwards until we find the information for the current. And here it is. Okay, the 30 centimetre length of conducting putty has 0.15 amps of current flowing across it, and its resistance is 36 ohms. So we just need to calculate these. I haven't got my calculator. You do know if you don't have your calculator, if you leave it like this, you're going to get 1 mark for writing that. You're going to have your calculator in the exam. You're going to work that out. Okay, so now we're on to C. A second set of data was obtained using thicker pieces of conducting putty. Both sets of results are shown in graph 2. So here we have graph 2, thinner pieces, this line with the resistance increasing and the length increasing. Thicker pieces, this line. What is the relationship between the resistance and the thickness of the conducting putty? So it's not asking about length, it's asking about these thicker and thinner pieces. So it's saying, what happens to the resistance when you change the thickness? Well, what we do is we look here and we go, okay, which one's got more resistance? Well, the thinner pieces. So now we need to write that. So we say, the thinner the piece, the more resistance. Because that's the relationship. Remember, a relationship is always the bigger the X, the smaller the Y, or the thinner the X, the longer the Y. So we're saying the thinner the piece, the more resistance. And that's a simple relationship for 1 mark. Pardon me. Now it says, name one error that may have reduced the accuracy of the results. Now, examiners love asking questions like this. They're saying, imagine you were doing this practical. Think of an error that might have meant these results were not exactly spot on. And sometimes there's a huge list of possible things you can say for this in the mark scheme. You can say things like, maybe they were not exactly measuring the diameter here. They've not said what the diameter of these thinner pieces are. They've just said they're thinner. Some of them may have been thinner than others. Some of these thicker ones may have been thicker than others. Maybe they should have exactly measured the size of these. Now, that's the first thing that leaps out to me as an error. And you just think, what would it be like if I actually did this? Or if I described this to a year 9? If I said, I want you to make some thicker pieces and some thinner pieces, they might have gone, well, what do you mean? What do you mean by thicker or thinner? So we can say, some pieces may have been thicker or thinner than others. Now, you might be thinking of some other errors. That's just the first thing that popped into my head. Then it says, how could the reliability of the data have been improved? Every single time they say reliability, they're talking about repeats. So you always write, repeat the experiment. These days, actually, they've moved on to asking about repeatability and reproducibility. And you probably remember that from doing all of your coursework. But whenever they talk about reliability, they're talking about repeats. And if you repeat it, it's repeatable. And if someone else repeats it and they get roughly the same result, it's reproducible. Okay, so a big question in the total of 10 marks. Lots of different variety of things in there. Remember your calculators, people. Do not go into your exam without your calculators. I'll never speak to you again. But this is a good question to really practice your skills. And remember, You can get any of these exam papers from me when I do lunchtime revision. So that will be Monday, Thursday and Friday in my room 43. So hope this was helpful. Maybe I'll do another one. Maybe I'll do an essay question next time. See you later.